तो नहीं, हम लोग तो
Okay,
वीडियो मतलब लाइव सेशन ज्वाइन किए तो अभी तक recording नहीं।
I'm putting it
नहीं
to
किया।
recording. Fine. So let's
ज्यादा
start
देर
with
मत
house
करो।
robber. Has anyone solved this?
हाँ मैंने बहुत पहले कर लिया, या डिस्कस पहले।
So what we discussed yesterday in the previous session, how to solve this question, house robber. What will be the recurrence relation? What do you think? Okay, since it cannot be solved without dynamic programming here, I have to solve it using recursion. Since you are to see only the recursive approach, I will be solving it in separate IDE. So let's go here,
ओके
IDE 1. तो डीपी का प्रॉब्लम है, ये नॉर्मली बनने नहीं वाला, ठीक है।
हाँ हाँ, पास में।
आ जाए C++ आईडी है, ठीक है। चलो यहाँ चलते हैं और देखते हैं कि इसको रिकर्सिवली कैसे सॉल्व करते हैं। फाइन। तो क्या बताओ कि इस प्रॉब्लम को सॉल्व करने के मेन रिक्वायरमेंट क्या है, क्या क्वेश्चन में क्या बोला है। व्हाट डिड द क्वेश्चन आस्क अस टू डू? इट सेड दैट इफ द रॉबर इज सपोज रॉबिंग दिस पर्टिकुलर होम, it cannot rob the adjacent home. Am I right?
यस यस।
Adjacent home cannot be robbed. It has to skip this home and go to the next home. Fine. Now, for a particular cell, if it is to be robbed, right? If this cell is to be robbed, I have two choices. I can rob it. It will give me a path. I may not rob it. Correct? We have two choices. If I am not robbing it, then where can I go? What do you think? This cell 3, if suppose I am here right now, I wish to not rob it. I won't consider this for robbing. I can start then. I can go to find what can be the maximum cost for me starting from its next adjacent home. Correct?
यस यस
From here. And if I am robbing it, I am right now at 3. I decide that I will rob it. Then from next onwards, whatever cells are left to me, I have to skip the adjacent one, whatever it is, XYZ. I have to skip this and start from, if suppose this is index I have to start from index I plus 2. From here, I will have a choice of continuing my robbing work, and whatever may be the final amount, the maximum amount I can get, I will add that to my current amount after robbing 3 and will get my result. That's what is the choice. Fine. So let's see how to recursively frame it.
So can you skip to consecutive?
Yeah, you can. You can. There is nothing as such. Suppose that I'm right now here. I wish to not rob it. I will go here. I wish to not rob it as well. I wish to just rob this last home. That can be a possible choice. Among all choices, will generate using recursion what? All the possible solutions for us. Correct?
यस यस।
And among all possible solutions, I will keep whatever is the most profitable for me. Correct? That's all. So let's go on. Let's move on. So let me just remove everything. Okay, so let's define the function. What it will do, let's make it void. And let us have the answer here, anti-answer. What is my final answer? Let it be initially 0, that I have more or less every house will have some positive cost, and the minimum I can have among them is 0. Correct? Now, next, what we should do? What we should include for our function, what do you think? Void, let's say maximum cost. What is my problem? Without alerting, what is the maximum money that can be grabbed from all the houses? So max cost, let's say. What do we require? We require the array, right? Array. And let us first initialize this to 232, the example given to us. Now, what is the size of the array? Let it be 3. How will you solve it? What do you think? How will you solve this? what will you contain inside your function? Tell me that. What should be contained inside the function?
Like
The
maybe
index of the element.
Right? Index. I just
Yeah.
require the index here. Now what will happen? What is the base case? Can you tell me that? What is the base case?
like when array will be the zero length.
If array has, if I have exhausted all my indices, right? I have
Yeah, n equal
gone
to
out of the bound of my array. That means my
Yeah,
index has
equals to
reached the value of n. Then I will just say what?
return.
What should we do? What should we do?
Return
Return the answer. Like if we do-
We'll simply return that. No?
Okay, so let's do one thing. Let's not make it void. Let's make it int. Correct. Let's make it int. How will we handle? We'll see that. Okay. If index is n, we have one thing for sure, right? We have reached here. This base case is equivalent to what? Can you tell me? I have exhausted all indices. Checked for all indices, have included whatever I can. Now what I'm left with? Nothing. So I have to return 0 from here. This is equivalent to what? Can you tell me? This case is equivalent to as if I am left with an empty array.
Yes,
The array itself
yes.
is an empty. From here, maximum cost that robber can got is 0. So I will be returning 0. Getting the point?
Yeah,
Yes,
yeah.
yes.
Correct? Okay, fine. Now next, what we should do? What we have checked for? If I'm at the current index, what should I do? So you have to keep a marker. If I'm not wrong, you have to keep a marker. Is it?
We will.
If I'm right now
Yes.
standing here, if I'm right now standing here, I have to check whether my previous index has been robbed or not. Am I correct?
Yes.
That's a necessity for us. So suppose that, or else somehow else we can handle that. So let's do one thing. Let's handle. Okay, I will come to that later on. What we should do right now, whatever index I'm at, okay, we won't care whether my previous index was robbed or not. If I am right now, just assume that if you have reached this index, if you have reached here, that means it can be robbed. That's how we are framing our program. How we will frame, we'll just see that. Okay, if I'm right now at index, we have two choices. What are they? What do you think?
Like based
Include
on the
this,
last index. Yeah,
include
based on
this,
the
or
or
don't
doesn't.
include this. That's all, only two choices. So I have firstly one thing. Return answer 1. Sorry, let's say we have one answer that I will keep, or let's say cost 1. Cost 1 I will keep by, suppose this is a choice, this is the cost I am getting after including the index element here, right? I will include this index element in our cost. So how should I include that? Array of index plus what?
Max cost.
Max cost of what? From where to where? I have included the index. So now where should I go next? What do you
Index
think?
plus 2.
Index plus
Index plus 1 to
2.
Index plus 2.
2
I
2.
won't be going to 1 because
Okay.
since I have included this index, its adjacent cannot be included.
Yes.
Correct? So you cannot go to index plus 1. Next, what we are left with? Next, another choice we have. Don't include this. Don't include this. So
Yes.
array of index, this won't be added. We want to just calculate. If I don't include this, I can definitely go to
Index plus
this
1.
Index
particular
plus 1.
index, right? And the maximum of these two, whatever is the result, I will return that.
Okay.
Correct?
Yeah.
Return
yeah, yes.
maximum of cost 1 and cost 2. Now something we should change inside our function. What is that? What do you think? Something we should change. Suppose that
Yeah, based on the we have to keep one marker based on the last index.
Okay,
we
to
should explore only.
We can't drop the
suppose-
cost in the last. Na? We have to
suppose
keep
that
that.
I am standing here at the last index I am standing and I have included this. Where
Yes.
will be my next pointer will be going?
Yeah.
This is the last index n-1, let's say. So now my index,
Huh?
I am taking my index pointer to where? Can you tell me that? To n plus 1, right? So
Yes.
index
Huh?
not necessarily mean to have a value of n. It can jump the value of n to n plus 1. So how should we maintain this? What should we say?
Okay.
Greater than equals to.
Okay.
Exactly. We have to say that.
Index
Okay,
less than equals to.
no,
Greater
if
than.
it is greater than
Equals to.
equal to n, we have to return 0. That's all.
Mustafi, we have to check one more thing, that we have our last and the first cannot be taken, no?
Sorry.
The last and the first one can't be taken together. And
That will be handled. Don't worry on
that will
that
handle.
automatically. Okay. So I am just running it, let's say. See out what is our function? Max cost. Max cost of what? From where? From index 0. Let us try running this. Whether we are getting the correct answer or not. Okay, sorry. Always I take Python based syntax. That's the problem. Let me try running this.
Array.
Okay, yeah.
Array is not.
Yeah. Sorry for that. Is the answer coming good? 4?
Yeah, it should be 4 for this.
Okay, let's say we have an array of 2 elements, 4 and 3. So definitely the answer is 4 right here. Let us, and let's see whether our answer is coming good or not. It is coming good.
Mr. Can you give the 4 input for like length of 4?
Sorry?
And like 4334 or 433?
4. Okay, which there is a test
5.
case for this. Okay. Let me just take this as well. 1, 2, 3, 1. First, let me take this, then I will go for your test cases. 1, 2,
Okay.
3, 1. Right. What is the expected answer for this?
4.
Okay, the answer is
Array
coming.
should be n should be 4.
Length
N should be
will
4.
be
Yeah,
4.
yeah.
Then line number 5. Good. 5 yes.
Let us go ahead now. Yeah, answer is coming good, right?
Yeah.
Answer is 4. Okay, now give your test case. What you want to do?
4.
Second test was of the lead code, right?
4.
Yeah, everything is from the lead code. Answer is also 4.
Okay.
Then 1, 2, 3, it will be what?
3.
The output is 3. How? This is strange, right?
Why it is 3?
It should have been 4, I guess.
It should be 4.
Last and the first can't be taken together, na?
Is it
That's
given
why
in the
it's
question?
3. Yeah.
Okay, it will automatically contact. Let me just see. Where is it?
Okay, 2 adjacent, like last one and first one are 2 adjacent.
Okay.
Okay, that's given, right?
Circular.
Okay, yeah. I
Circular.
mistook that. Sorry for that.
And
Thanks for saying me.
1, 2, 3.
Then what should we do?
We have to check.
Okay, this is a circular home that they have arranged. 1, 2, 3. This is the home. Fine. So one thing separate, we should have some separate test cases, but what are they?
If len of if n is 1, then we should return 0. Like it will be the first and last, right?
Yeah. But should it be, is it the case? What do you think? It's not even given here, given an integer. No, return the maximum amount. Okay, it will automatically be contact like that. Fine. Okay, so let's handle that accordingly. Let's handle that accordingly.
We understand whether we have...
But that's not given as of now. If n is 1, just let's say if index is greater than equal to 0, or we can have another condition here only, or n is equal to 1, we can return 0 straightforward from here, right? Next, what we should do? How do you handle that the first and the last element together won't be taken care of? How would you handle that? Tell me.
Hello.
Yeah.
We can do one thing.
What would you do? How would you keep a marker here?
We can take a max of.
We can do one thing.
Sorry.
We can use the busy one. You will like.
That's what I'm saying. Let's keep a marker.
Hello.
Let's keep a marker that my first, if suppose my first element has been visited, Let's keep a marker. Every number is positive, right? So suppose that I am to include this. I am to include this. Hello?
Hello, Mustafi. We can do one thing. We can start two recursive calls from the main function. We start from 0 and the 1, so it will not concern each other.
But that's not
Begin.
required, I guess.
We start from one
Required.
begin, and we start again from the begin plus 1, and we take the maximum of both.
My voice is coming to all of you or not?
Yeah, your voice is clear. I think visited will be the marker will be the best option.
Okay, let's do one thing. Let's keep a marker. Let's keep a marker. Whatever I'm visiting right now, let me mark it to be -1. Since I have included this here, okay. I have included this here, and what I'm gonna say, let's store the value somewhere. What is that? Int, let's say, cost included is equal to array of index. Correct? The cost that I'm gonna include, let it be array of index here, and I will just push it here. Cost included. And what I'm gonna do, I'm gonna just say array of index, let it be -1. That's a marker that this particular cell has been visited and its cost has been included for the current function call. And post, once the function call is over, what I'm gonna say, array of idx, let it restore its original value, cost included. That's all. Post that, without including it, since now it has retraced its value, that means it is not more included anymore. I will be going for the second function call. That's all. Now, since the array is global for us, what we can do, we can just check if array of idx, sorry, if my index is n-1, let's say, then what we should do?
We need to check whether array of zero position is negative or not.
Yeah, if array of 0, sorry, if array of 0 is -1, then what we are going to say, just return 0 from here. It cannot be included, no point of going further as well. So just return 0. That this is my ending point. Since I can't include from the current index, it's as if my entire array is empty from this point. So return 0. If it is not, then how should you do that? What should you do as per this?
I do including
Then we can return the value as it is, right? Array of n-1. Since we have reached here, that means definitely it can be included. That's how we are framing our program, correct? Let me try running this now. It's that a few base case more are getting added here, and I have little more analogy we are adding to our program. Okay, what's the solution? It's 3, right? It's coming good. Anything else you want to test with?
Can you scroll down, Mustafa?
Yeah.
Can you scroll down?
Any further test case you want to test it with? You can.
You have visited for like 22.
Visited is a marker.
Line number 22.
Yeah, visited
you
is
have
a marker.
marked it, and after 23 you change that values.
Yeah,
then what will be
-1.
the cases for line number 23?
Sorry. Okay, let's have a dry
the
run.
cases for line number 23.
Let's have a dry run. Correct. Let's have this array 1, 2, 3. It's gonna be huge, I guess, the tree. Okay, we started from index 0. Am I right?
Yeah.
You started from index 0. Now the first call will be going where? First call will be starting here, right? If I am not wrong. This cost 1. From here, you have two values to be calculated. One is cost 1, another is cost 2. Correct? For calculating cost 1, what do you do? You first calculate cost 1, if I am not wrong. Is it? Hello?
correct.
Yes.
So for calculating cost 1, we have a cost included, that this particular index. At right now, I'm at index 0. Correct? At this index, I am right now. So at cost 1, we'll be including this. Correct? 1 plus. We'll mark this value as -1. That okay, it has been included. Let's mark it -1. Now next, what we should do? Marked it. Okay, included that, marked it. Now we made a call from where? Made a call to where? Can you tell me? After I mark this -1, that means it has been included.
+2.
3.
Yeah. From 1, I go to, if I'm at index 0, I go directly to index 2. That okay, this adjacent one can't be included. We'll just go to index 2. Now next, we are here. This is my next function call. Now, for this function call, what conditions will be checked? What do you think? What conditions will be checked
About
here?
2 from 2
Like it's -1, then it will return 0.
Okay, let's see that. Fine. So it's given here. Index is -1. We will come here at this point. Index has not gone greater than or equal to n, or n is not equal to 1 either. This will be skipped. Will come here. So array of 0 right now. See, array of 0 is -1. Am I right?
Yes.
Array of 0 is -1 for here. So we'll just return 0 to the previous function call. That is, at cost 1, it was waiting for that what can be the maximum cost we can get from this function call. It is returning 0. So let's add 0 here. Correct? So 1 plus 0, this is the maximum cost we can get for. That is the calculation for cost 1 for us. Now next, what will happen? Based upon the function call, what will happen next? Cost 1 has been calculated. Cost 1 has been calculated. Now what will happen? Tell me. This function call at index 0 was waiting where? Can you tell me? Waiting here, right? Now what will happen? Right now the flow of control is again back to this function, inside this function call, which was waiting at this line. Now next, what will happen?
Cost 1 calculate.
See here, see what is happening.
Then it will like update the values of the busy marker.
Cost included was storing what? The original value 1 for this array. Am I right? Cost included was storing what? Cost included was storing the value of 1. Now, after I have stored it, I have updated the value, right? And then called for the cost 1 function. This function call is over. Now I will be just putting it back. That okay. Once I have included that to my current function call, whatever maximum cost was possible, I have got that. Now I will go for without including that. So I have to restore its value, right? So I just do what? Whatever is the current index value, I just restore it. And then go for the cost 2 calculation. That's all. Let's go there. Cost 2 calculation will be what? Will be where? From which function call?
From 2.
From 2, right? This is the array, remanent array from where the cost will be beginning. Fine.
Line number 26.
So cost 2 is dependent on this function call. Whatever will be returned by this function call. I am right now at this function call. What should happen here? Tell me. Tell me what should happen.
Okay. Then what it will do? It will like call line number 24 23 again. Like it will add it, like it will take 2 and then again call the like next function, means max of cost of index plus 2. So it is out of bound, so it will return 0.
So it is a
0. So
this is a new function call. Am I right?
like
This is a
index
new
is out of bound.
This is a new function call. So what will happen? I'm standing right now at this point. What will happen? Tell me. First,
so it will return cost 2.
For this function call, what parameters will be having? First, a cost included. What is the cost included will be for this function call? Tell me.
2.
Cost included will be storing 2. Next, this 2 will be marked -1. Next, what will be happening?
-1. Okay.
Next, what will be happening? We'll calculate cost 1 for this.
Calculating cost 1.
What will be that?
Equals to 2 plus.
Will be 2 plus what? Plus
Index plus 2.
Index plus 2.
That means
max
array out of bound.
Max cost of index plus 2.
And
array out of bound. Array out of bound. So it will return 0.
Yes.
It will return 0. So 2 is
condition
returned. Now it will go for calculating cost 2. What that will be? Without including anything. So before calculating cost 2, what will happen? Can you tell me that? Before calculating of cost 2, what will happen?
2 की वैल्यू -1 से दोबारा 2 होगी.
एग्जैक्टली -1 थी, अब -1 से वापस 2 पे रिस्टोर हो जाएगी और फिर एक cos 2 की फंक्शन कॉल होगी.
हाँ, रिस्टोर होगा.
cos 2 की फंक्शन कॉल क्या होगी? किस एरे पे? सिर्फ 3 पे. ठीक है.
3 पे।
Correct.
3 के लिए फंक्शन कॉल क्या है
हाँ।
बोलो? 3 के लिए फंक्शन कॉल क्या है? 3 की अपनी क्या होगी?
3
कॉस्ट
के लिए
इंक्लूडेड।
कॉस्ट इंक्लूडेड अगेन 3।
कॉस्ट इंक्लूडेड अगेन
हाँ
सिर्फ, सो कॉस्ट इंक्लूडेड फिर 3 हो गई। नेक्स्ट
उसकी वैल्यू
नेक्स्ट
-1।
हाँ,
इसकी वैल्यू
उसके
-1 कर
वैल्यू
दो। 3
मतलब
कॉस्ट 1
माइनस
क्या
कर
होगी?
देगा।
3 प्लस
उसके
i
बाद
plus 2 0।
कॉस्ट
I plus
3
to not
प्लस
access
मैक्स ऑफ
unbounded.
इंडेक्स आउट ऑफ बाउंड, इट विल रिटर्न 0।
लेट मी सी। रुको रुको रुको, कॉस्ट 3 पे जैसे ही आ रहे हैं तो एक चीज देखो क्या हो रहा है। कॉस्ट 3 पे जैसे ही आ रहे हैं तो ये फंक्शन कॉल हिट हो रहा है, राइट? इफ कंडीशन हिट हो रहा है कि मेरी इंडेक्स n-1 हो गई, इजंट इट? ये तो इधर जाएगी ही नहीं,
हाँ, इन
इधर
माइनस
पे तो
1 पे
जाएगी
आया।
नहीं। n-1 पे आ गया तो ये
हाँ,
कंडीशन चेक होगा।
हम्म
ये कंडीशन चेक होगा। क्या हो रहा है हमारे पास? 3 जब बच रहा है, सिर्फ ये कंडीशन चेक होगा तो हमारे पास तो रहेगा क्या? एरे
else
0
condition में
क्या हो रहा है? एरे ऑफ 0 -1 है प्रेजेंटली?
नहीं है,
नहीं है, एरे तो 0 1 है, रिस्टोर हो गया पहले से ही, तो क्या होगा?
else कंडीशन में आके आएगा।
एल्स कंडीशन हिट करेगा एंड इट विल बी रिटर्निंग बैक। कॉस्ट 2 विल बी रिटर्न्ड एज 3 ओनली। single
Yeah.
single single element, right? For us now, what will be happening? What do you think? From then cost 2 for this function call is getting returned as 3. So we have, for this particular function call, we have two things. Cost 1 is 2, cost 2 is 3. Maximum of both will be getting returned. What is that?
That is 3.
3. And that is getting returned here. That is getting returned here, right? Then it will be returned where? Cost 2 of the initial function call. That is, what is the maximum cost that we can get here is 3. Now we are left with the original function calls 2 value. What are they? Cost 1 and cost 2. Cost 1 is 1 and cost 2 is 3.
3.
Maximum answer I can get after including this 1 and without including this one. One is 1, another is 3. Maximum of both is what? Maximum of 1
3.
and 3 is 3. So 3 is the final answer. That will be it.
Correct.
Any doubt anyone is having for this question, how it works? This is basically a kind of knapsack where you add more conditions. That's all. इससे ज्यादा कुछ नहीं है, ठीक है? कोई डाउट है किसी को? टाइम कॉम्प्लेक्सिटी क्या लगता है, कितना है?
Time complexity
2
बोलो।
and 2 power of n.
Yes, किसी भी सेल पे, if I'm right now, in the worst case, if I'm right now at any cell I, let's say, or index I, it has two choices to be
Yes,
executed. So if suppose at index 0 I start, it has two choices, then from index 1, I can go to index 1, I can go to index 2.
Again 2 choices.
Again two
Again.
choices from here, again two choices from here. And
Yeah, 2 to the
there
power
can
n.
be
So
at
level
most
wise it is
n
implemented.
levels.
Yeah,
There can be at most n levels, and for each level, what is happening?
2 choices we have.
For each level, we are having not exactly. It's going first. We have one choice. Then it is multiplying by 2. Then we have 4 choices. 1,
Yeah.
2, 4. So at the end level, what we are having? 2 to the
2
power
raised
n
to
choices.
n.
So for a recursive solution, the time complexity is 2 to the power n. Okay.
Okay.
What is the space complexity? Can anyone tell me?
So
Wait,
order of
space
n,
complexity.
Yeah, बताओ, कोई बताओ. Space complexity कितना है?
it's order of n.
Okay, how? Yes, exactly. That's order of n.
We made one array only.
Like at most like n भी नहीं होगा और कम होगा. Sorry.
We are calling the recursive call only, but we're not using any spaces.
Okay, so for each recursive call,
Highest height of the stack tree.
yeah, for each recursive call, what happens? Let's suppose how it is happening. Let's go by the function calls. First, I am standing at index 0. It will go where? It will go, let's say, in the worst case, what will happen? What do you think? You start from index 0, then what happens?
It will call from first index, so there it.
Okay,
It will
it
call.
will not go from this, but something like this will be happening. In the when I will not be including index 0 in my answer, it will call for index 1, right?
Yes.
Then
Yes.
again, it will, when I'm not including index 1 as well, it will call for index 2. It will similarly call for index 3.
3.
Dot dot dot. What can be the maximum number of levels? What we can have?
N.
At the
NS
end,
N.
I am calling the n-1th index, just like
Yeah.
this.
Yes, sir.
So if suppose from 1 I am here, I call for, if I've included index 0, I will call for index 2, then it will call for index 4, then it will call for index 6, so on till let's say index n, if it is even. Correct? Once this function has been executed, it has returned some value, its space goes off, and we go for calling some other possibilities, that is index 7, let's say. Correct? So once a function has been executed, its memory is wiped off. Correct? So when you reach at this point, no more branches or your nodes, let's call them nodes. No more nodes will be having their memories on right now in my stack memory. We are left with at max how many function calls here? N function calls, I guess. From 0 till n-1, we are having n function calls in our call stack. You keep on calling. At the end, whatever is the end of this entire branch I am having, whatever is the last function call, once that's executed, its memory is wiped off. Right? It's not that for entire branches, every time, every function is having their memory on. That's not happening. At max, for a branch, when you reach the end of a branch, okay, then from root to this branch only, that amount of memory is being allotted. Your call stack is holding that amount of memory, let's say. Fine. So at max inside the call stack, how many memories, how many function calls we can have? N. And for
Yes,
each function call, we require how much? Let's say some constant memory K. For each function call, you require some constant memory K. So at max, my call stack is having how many memory? How much memory? At max at any time. At any time, let's say, it can have any branch. The maximum number of nodes a branch can hold there is N.
N.
So the maximum memory that my call stack can hold at any point of time is how much? N into K. So what is the time space complexity here? Big O of N. K is a constant, you can neglect that. Big O of N. Any doubts till this point? Recursive
No.
calls do require memory to be allotted, right? Because they are function calls.
Yes, yes.
Any doubts anyone is having? Please tell me. कोई प्रॉब्लम है तो बताओ.
No, no, no problem. We got
किसी को कोई
everything.
प्रॉब्लम है तो बताओ. So this is the recursive approach. I'm putting that over the doc. Okay. Put this over the doc, just a minute. सबको समझ आया ना सॉल्यूशन, या कोई डाउट है? किसी को है तो बताओ. हेलो.
हाँ
नहीं
हाँ
है. नहीं.
Hello.
Yes, yes.
I have sent one code on the comment section. You see that?
Is it working? You dry run that.
Yeah. I have submitted that in this August form.
Then that's correct. If it is getting accepted, then there is no problem.
The one is starting from the index 0 and the second is for starting
Completely fine. There is no problem on that. Completely fine. There is no problem on that. If it is getting accepted, there is no problem. But more or less for getting accepted, it should be a DP based solution. Because
yeah, it's a DP based solution.
Then that's fine. No problem. Just let me put everything over the doc. यार, what is happening? The previous day आपका इसका हुआ था क्लास LLD का.
क्या हुआ था?
कितने लोग आए थे?
वैसे भी क्लास भी कुछ ज्यादा कुछ नहीं हुआ, लाइक हार्डली 40 or 50 minutes हुआ.
समझ आ रहा है ना LLD में आपका? मेनली तो अभी प्रैक्टिस सेशंस तो बाद ही में आएंगे, जितना मेरे को लगता है, बेसिक्स के बाद ही. अरेंजनेस सर्कल अभी मुझे को ये दिखा आपका. हाउस रॉबर 2 और मैं भी कोड डाल रहा हूँ इधर रिकर्सिव सॉल्यूशन वाला और रिकर्सिव सॉल्यूशन. Okay, have given that. Anyone can access from here. Fine. Let me just put everything in a new page. Okay, let's move on to jump game. How many people have solved this jump game?
Yeah, that was easy for me.
लाइक सॉल्व तो ही है.
कितनों ने किया है जंप गेम सॉल्व?
मैं बहुत पहले किया है.
हाँ
उसके बाद
देखो,
पता नहीं.
बोलो कैसे करोगे इसे? What do you think? Take 5 minutes and have some thought process that how will you solve this jump game 2? This is actually related to DP. Fine.
Shit.
Take 5 minutes, think and give me the answer. How would you solve this? Okay, tell me, how many of you got the solution?
like recursive approach तो आया नहीं,
चलो
मतलब
देखते
आया
हैं।
है, मतलब
इसमें
सबसे गंदा है, मतलब
फंक्शन में
वो
हमारे
ब्रूट
पास
फोर्स
इंडेक्स
वाला।
होगा पैरामीटर में।
ठीक है,
मतलब मैक्सिमम जितना जंप्स कर सकते हो उतना ही ले लो।
नहीं नहीं नहीं, क्या करेंगे अगर मैं भी एट मैक्स इंडेक्स में मैं इफ आई एम स्टैंडिंग एट दिस इंडेक्स फ्रॉम वेयर टू वेयर, हाउ मेनी चॉइसेस डू आई हैव टू गो? टेल मी दैट.
Until the number, like the index
Sir,
will be
array
the
of index, nums of index choices only.
Yeah, if I am at right now at this
index plus array of index.
so I can go to index plus 1, all choices I have, right? Index plus 1 I can go, then I can go to index plus 2 and so on till what point?
less than equals to index.
Nums of
Index
index.
plus array of index.
Index plus array of index, right? Is it so? Tell me, is it so?
Yes.
Yes.
नहीं, कुछ छोड़ रहे हो. Something you are missing. What is that? If the last, let's say I'm standing at index, this is my array. I'm standing, let me have an array like this, 1, 2, 3, 4, 5. If I'm standing at this index, till what point I can go maximum? Standing at index 3, then what
Yes,
point I
yes.
can go maximum?
Less than the length of the array.
Yeah, so it should be what? This should be what?
Less
This
than the
less
length
than
of
length of array.
Less than
max
less
of
than
this,
n.
max of this or n minus
less
1.
than, yeah.
Max of this or n minus 1. That's all. Simple thing for us. That's the maximum function call I can have. बहुत poor approach है ये. Definitely इससे solution तो नहीं बनेगा, but recursively देख लो. मोरल से रिकर्शन का प्रॉब्लम है नहीं.
तो रिकर्शन ट्राई किए थे, नहीं हो पा रहा था.
ठीक है, तो कैसे होगा चलो देखते हैं. रिकर्सिव सॉल्यूशंस बहुत पुअर सॉल्यूशन है. डोंट वरी ऑन दैट. सो लेट्स गो अहेड एंड सी हाउ वुड वी सॉल्व दिस. लेट्स मूव ऑन. सो क्या है हमारा, व्हाट इज दिस? मिनिमम नंबर ऑफ जंप्स, राइट? वी रिक्वायर टू रीच वेयर? min jumps. This is the min jumps for us. Let's change the array with what? This is my test case 23114, right? 23114. Fine. And what is the length of my array? It is 5. Okay, fine. What is the base case? Tell me now. What is the base case? And it should be now minimum jumps. What is the base case? Tell me that.
Like when we'll reach
Index
n minus
is
the
1.
end of the array.
That means if the array is empty, let's say I have exhausted all the elements, array is empty.
Yes.
Then what we should do? Index is definitely has gone. It can be possible, right? Okay, it may not be possible. As of now, just think the index cannot exceed the value of what? Because what we are going to handle, if I'm right now standing at the current index for int I equals to my current index, right? Let's say index plus 1, I less than equal to what? How should I handle
Max
this?
of n minus 1.
N minus 1 and index
Array
plus
of
Index plus
Array of
nums of index.
right? I plus plus. We can have a function call that, okay, from here to where I'm jumping,
All the like all the test,
Maximum of
all
it.
the maximum of these two.
yeah. So let me have a int minimum answer. Let's say my answer I am or jumps. I will keep here the minimum jump starting from this index. That is possible. Starting from this index to the last index. Okay. Let it be initially 0. Correct. Let it be initially 0. If from this index, let's say from this index, I am going to in any of the ith index I am choosing. How many jumps I have made?
1.
Like
Okay.
arrow index.
So right now, what is the current number of jumps? Let's say int number of jumps required. Number of jumps I am making. Okay. Please don't shout. Number of jumps I am making to the ith index. What is the total number of jumps? Okay, I'm starting. I'm right now at index idx. to any of the ith index, I will jump and will make it to the last index. What is the total number of jumps I require? Can anyone give me the relation? From
In 1
index
plus
idx,
minimum
I'm going
jumps.
to where? I'm going where? From index idx, I'm going to any of the ith index. And using this ith index, I will go to the n minus 1th, the last index. That's what is the question asking me. What is the relation? Can you tell me? One jump is required to go to the ith index. Am I right?
Hmm.
And
Yes.
Yes.
we need to
Okay.
calculate what is the
Minimum
minimum
jumps
number
of
of
5.
jumps we require
Five.
from
Five.
the ith index. That's all. Correct. Now, whatever is the answer. So let's say the jumps. Okay. The maximum number of jumps, if I start from here till the end, till the last, is always n, if I'm not wrong. So let's keep initially the number of jumps to be n for betterment. What I'm gonna do, I'm gonna just say, if suppose I'm just gonna update jumps will be equal to minimum of its current value, and number of jumps I have just calculated now by transiting to the ith index. Just update this and post that, return the number of jumps. Correct? Or let's, return the number of jumps. That's fine. Now, based upon this code, whatever we have written recursively, what is our base case? What do you think? So it is guaranteed that you cannot go beyond n minus 1. What is the base case we have?
If I equals to n,
If index
What
reaches
is
n
given
minus
here?
1, return 1.
Just let me see. What are the constraints? Okay, fine. Number of length can be 10 to the power from 1 to okay. So suppose we are having at least a single index will be present for us. That's for sure. So what is the case? What should we do ahead? At least a single element will be there for us for sure.
Then length of like if the array will be length 1, then we should return 0. Like we are at last index.
If suppose the index is n
index
minus
equals
1,
to n minus 1.
we can return 1. We have reached our destination.
No, like 0 we should return. Like even if we are at like last position, then we reached. Like once we can see one test case here.
If we are at the last position, that means we have reached the destination, right? Nums
Yes,
of
yes.
n minus 1. That means
Then-
one way we have got for sure. Correct?
Like we
At
should
least one
return
jump
0,
is-
right? Like
Okay, yeah. You're right. We require 0 jumps for that, right? We have reached that. Yeah, you're correct. We have reached the n minus 1th index. That means, and right now my index is that. That means no more jumps are required. We can just move on from here. 0 number of jumps are required to reach the n minus 1th index. Fine.
Yeah.
Next, what? Is it sufficient or we are missing something? We cannot go beyond n minus 1 based upon our code. Anything we are missing?
Yeah.
No, I guess.
No.
Okay. Let me do one thing. Let me keep it to be n plus 1. That's a hypothetical value. Am I right? N plus 1 number of jumps will never be required for what?
To reach like at
To reach the last index. Suppose that even after all, suppose that my last index is not at all reachable from my current index. I'm standing here, let's say, because it can be 0. It is possible that your array is something like this, 1 0 0 0. So if I start from here, I can never reach this point. So once I'm at this function call, I can set that let the number of jumps required to reach this particular point, let it be n plus 1. It is never possible, actually. Fine.
Yeah.
So what I'm gonna say, even after from here, let's say I have 2 possibilities. One is to go here and one is to go to the second step. But from these steps, I cannot go to the last index. That's not possible as per my given case. So the jumps will never be updated. This jump for the function call that starts from index 0, this will be never updated. This will always be remaining in n plus 1. When it shall be updated, it will be updated only when there is a minimum number of jumps that is taking me to the n minus 1th index. correct? So
Yeah.
we should say something. Okay, let's say we should handle for something. I guess it is possible that always it's not there, and minimum number of jumps. Is it guaranteed here that there will be some minimum number of jumps?
No.
Maximum.
Like there.
I guess this is guaranteed, maybe more or less. If suppose we can handle it the way such that there may be some cases like we can never reach our particular, we can never reach the last index. This is possible. So what we should handle based upon that? Based upon that, what we should say? It may be possible that we may never reach the last index. What should we do? Minimum jumps of I, let's say it never takes us to the last index. So I will just say one thing. If my number of jumps that I'm having is equal to n plus 1, then what I should say that, okay, this is never possible because n plus 1 number of jumps is never required to reach the last index. In the worst case, it will be n. So I will say, if this is the case, return -1. That means it is never possible to reach the last index from here. So suppose that if I'm transiting to the ith index and this particular function is returning me -1, what I should say? What I should say?
Like we just return.
So I will just check if number of jumps is what, -1. Correct? Or if it is not equal to -1, then I will be updating my jumps. Jumps to what? Its current value and 1 plus the number of minimum jumps that is required to reach the ith index. That's all. And after updating jumps, if it is not at all updated, I will just return -1 from here. I will say from my current index, my last index is not at all reachable. So no need to count on that. If it is reachable, then some lower values than n plus 1 I have definitely got. So I will say return jumps. That's all. Let me try running this. What has happened? Sorry. Is the answer 1 for this case? The answer is 2, right? Something we have left. What do you think? Sorry. It will be minimum of, not max of. Something has gone wrong here. It is minimum of. Let me try running this. Yeah, answer is coming to. No problem. Any other test case we should try? Something like the 23014. Answer is again 2. Any other test case you people have so that we can search for that? 23014. This is just this, I guess. Answer is 2 for this as well. Let's say it is 000. What should be the answer for us in this case? 23000. What should be the answer?
2.
2, right? Let's see whether it is coming or not. See how slow our algorithm is, that it is taking so much of time. Yeah. 2, yeah. And if it is also 2, then what should be the answer? -1, right? It's not at all reachable. The last index is not at all reachable. Completely -1. No problem on this. Is there any doubt you people have with this problem? Anyone is having any problem?
No.
So basically, I have.
Yeah.
We started with the first index of the array, right?
Yeah.
First element of the array, right?
Yeah.
So we added to that particular the step we have removed from there.
Your voice
So
is.
when the array is changing, basically,
But why the array will be changing here?
so basically we start from the 2. If the first element is 2, so we have, right? We can 1 and 2, right?
Please repeat that. I am not getting why the array should change here.
So basically we have a for loop, right?
Yeah.
It's for the element that we have, that the number of the for loop will be the element that we have on the first index. It means 0 index.
Firstly, okay, let me have a dry run, how it is working. I am starting from the index 0, let's say. Okay, then I have two choices. I can go to, let's say, let my array be something like this, 2, 0, and then 2, 0, 2, 0, 2, 0, something like this, let's say. Then what should happen? I am starting from index 0. Where to where I can go? I can go to this step and this step. These two are my possibilities. Am I right?
Yeah.
I'm starting from index 0. Then I can either
Yes.
transit to index 1 or I can transit to index 2. No array will be changing. I just need to count starting from here in how many jumps I can reach the end. That is the question asking me.
Just we are updating the like
You
we are
don't need to
index.
update any array element. No array element will be updated here. You reach to element 1, then you go to index 2. You have two choices. Now let's first go to index 1. From here, there are no possibilities because you have the number to be 0. Zero amount of elements can be gone forward from this point. We return no possibilities from it. It returns -1. Now from index 2, how many possibilities do we have?
We have 2.
Yeah, we can go to what? First is
Like
this. Only one possibility is there. We can go to index 3. Once you reach the index 3, what is the solution? What is coming up?
Like,
Once we reach,
we reached the
we return 0.
destination like
We return 0. We return 0.
Okay.
Now from here, since I have made a jump to this 3, add 1 to this. That okay?
Okay.
From 3, I can reach the nth, n minus the end of the array in 0 jumps. That's for sure. This is the end of the array. From here to the end, that is itself, I can go to 0 jumps. I can make 0 jumps to reach that. So to reach index 3 from 2, I require 0 plus 1 number of jumps made. And from 2. So from 2, what is the minimum number of jumps I'm getting to reach the end? 1. Return that to index 0. Okay. From index 2, I have a path to reach the end. That requires 1 as the minimum number of jumps. Now let's say from 0, how many jumps would we require? What is the minimum number of jumps would we require to reach 3? Can you tell me? Can you tell me? From 3, we required 1. From 3, we required to reach the end in 0 jumps. From 2, we required to reach 3. That is the end in 1 jump. From 0, how many jumps do we require?
Usually 0.
From 0, how many jumps would be required to reach 3? That is minimum. I have made a jump to 2, right? I have made a jump to 2. Then from 2, what is the minimum jumps? I require
from 2 to
to reach 3, right? So 2 returned me 1. 1 is the minimum number of jumps I require to reach 3. So from 0, I have made a transit to 2, making 1 jump. What is the total number of minimum jumps to reach from 0 to 3? That is 2. This is the final answer.
Okay.
Getting the point? That is the thing.
Okay.
Okay, would anyone like to, since this is a very poor solution, in worst case, what will be the time complexity? Go to the problem once more, okay? You will have a good understanding of this. I am pasting the solution firstly. I'm pasting the code only, the function. Along with this, and let me just have this here. All of you can access this. And given here the jump game. What is happening, man? Pasting the question as well. Yeah. Correct. What is the time complexity of this? Can anyone tell me?
Maybe n power of 1000.
No, it's nothing like maybe. Let's see. So from 0th index, what is the
2
worst
power of 1000.
possibility? From 0th index, what is the worst possibility? I can visit all other index. Am I right? Something like that is possible. There can
I
be
would say complexity will be order of n, because if
Like at max, like
maximum n number of elements and each element is 1, 1, 1, 1, 1, like that.
Can it be like that? What do you think? I don't think so. This should be the maximum complexity. From 0, let's say I have, from 0th index, let's say I have n minus 1 choices. I cannot reach the last index, let's say. Possible? Possible or not? Last index, except the last index, I can reach all other indices. Possible or not?
yes.
Yeah, from 1 till n minus 2nd index. Now from 1 also I have choices to go to 2 to n minus 2. Correct? All possible options you can go. Only for the last branch, let's say. Only for the last branch. From n minus 2 I can go to. Once I reach this n minus 2, or somehow most haphazardly from the last branch I can manage to reach n minus 1. Then what should be the time complexity? What do you think? Let's say in the worst case, we are exploring all the functions. Then what should be the time complexity? Or somehow you miss this n minus 2. Only from n minus 2 it is possible to reach n minus 1. From 1 I can go till n minus 3. N minus 2 is not possible. Similarly from, there can be, let's say from 2 you can go to all functions and you can't reach from n minus 3. You can again go to n minus 3.
N to the power
n power
n.
So let's say we are having, it is getting multiplied by n, I guess, every time, isn't it? Just like it was going what? In the previous examples, it was getting multiplied by 2. Right now it is getting multiplied by n. First only one function call, then n function calls. Then n into n square. Then n cube. It goes up to n to the power n, let's say. Somehow, most haphazardly it is happening. Most probably it won't be happening, but in the worst case, it may happen. Then what is the time complexity for us? Exponential again. You have to just calculate n to the power 0 till n to the power n. All the functions needs to be calculated. What is the GP sum of this? 1 into a r to the power n. What is r? N. N to the power n minus 1, n minus 1. Yeah. So this is basically the time complexity for us is n minus n to the power n. One of the worst time complexities in exponential orders you can have. Fine. That's why this solution is not desirable.
No.
Would you like to see how the solution of DP works here?
Even greedy works here.
Greedy, not DP.
Like I'm saying, like I think we even have greedy solution.
Greedy will be a step, it might be, but if you would like to see, I would show you how it works.
No, when we start the DP, we will,
Yeah, at that time we can.
because we are not ready for that.
We want to see those recurrence relations.
Okay, is it fine for this question? Have you understood it or should I explain it again? Please tell me that.
No, completely got it.
All of you, what should I say? Or should I stop for some time?
Got it.
All of you? Hello?
Yeah, audible.
हेलो भाई दो
Hello.
जन बोल रहा है क्या क्या समझे बताओ
Yeah, Musa, I'm there. I'm
Yeah,
there.
you are audible.
या नहीं क्या करें सॉल्यूशन समझ में सबको आया या नहीं आया वो पहले बताओ
Yes, solution we understand.
Fine, sir.
ठीक है खैर चलो ये हो गया नेक्स्ट क्वेश्चन बताओ आप क्या सॉल्व करना चाहोगे लेट मी सी कौन सा अच्छा क्वेश्चन हम देख सकते हैं आज ये दो क्वेश्चन था आई हैव डिस्कस देम ऑल ठीक है आपका होमवर्क था दोनों हमने देख लिया लेट मी जस्ट चेक आउट अ सॉल्यूशन क्वेश्चन फॉर टुडे Okay, this is again a very simple question. Would you like to try this? This question. Okay, पिछले प्रॉब्लम में स्क्रीन शेयर नहीं था या था
नहीं था लाइक पिछला प्रॉब्लम मतलब
जब कोड कर रहे थे प्रॉब्लम में
हाँ
शेयर था
हाँ
या नहीं screen?
तब था
ठीक है लेट्स गो अहेड विद दिस अगेन अ सिंपल प्रॉब्लम बहुत सिंपल प्रॉब्लम है इवन की डीपी इफ यू टेक द सेंस ऑफ डीपी ये जो दो क्वेश्चन किया ये कुछ है ही नहीं वहां पे सबसे आसान डीपी में से एक डीपी कुछ क्वेश्चन है okay try this again very good questions
Your voice is breaking.
might be internet is going a little bit shorty sometimes every time my voice is breaking is it happening
No,
Hello?
not
No, no.
breaking.
think for this problem first what would you do
like at each and every position we have two possibilities whether to add or whether to not add like after adding
yes
we will return
Yeah,
each
yeah,
and
and-
every at each and every position. It's completely like
your task is to find all money sums you can create using these coins
yeah like this is
Knapsack, I
knapsack, like a direct knapsack.
it is a
Knapsack.
direct knapsack where you have to generalized knapsack where we can do what
Take or not take.
We have to return at each and every after taking and each and
every possibility we have to count here every possibility
Yes.
you have to count yeah
yes
so again see one thing this is not a recursive problem because n is 100 how would you identify you can have a recurrence relation here using if suppose it is not going 2 to the power 20 2 to the power 20 functions you have to evaluate what is the value of 2 to the power 20 can anyone tell me 2 to the power 10 is what 1024 so 2 to the power 20 will be what so let's say 1000 into 1000 so it is 10 to the power 6 this amount of functions we can evaluate why let's say each function takes k unit operations to be evaluated total operations what we are doing 10 to the power 6k it is lesser than 10 to the power 8 functions that's the max function that's the max number of what I should say unit operations you can do in a second correct so this is gettable 2 to the power 20 till n equal to 20 our solution is gettable but n is now 100 so 2 to the power 100 is not at all desirable correct it's hugely greater than 10 to the power 8 you cannot have that so definitely you have to optimize your solution based on what based on dynamic programming.
Yes, sir.
But let's
So-
first come up with a recurrence relation.
If n is greater than 20, we have to recursively, right? If
Yeah,
it
if n is
greater
going
than
greater than 20, no recursion, no total recursive solution will work in your case.
Okay.
Whatever is the
Okay,
solution,
okay.
whenever you see you have a problem on backtracking, okay? Backtracking is
Okay.
there, your recursion. This is not exactly recursion. Recursion is the way of implementation, as we have discussed earlier. That is a brute force approach. Likewise, that's what we are going to
Brute.
see here. How you can solve utilizing the brute force approach. The brute approach, whenever you will be taking for these cases, when this brute force and backtracking will be working, when you have constraints fairly smaller. Else, your solution will give huge time
n
complexity.
less than 20, right?
Yeah,
Okay.
n is less than equal to 20. That is the maximum list. Correct? For when?
Okay.
When my exponent is 2. For which cases?
Okay.
For which we are having exponents of 2, like 2 to the power 20. If it
Take
is
a
going,
note. Right?
if it is going 3, it will be again lesser than this. 20 will not be accepted. Something lesser, like 10, 12. If it is going 4, again lesser. Correct? If it is
Okay.
going 100, again lesser. Max to max for 100, what can be the desired range? What do you think? What can be the desired range of exponents? 100 to the power 3, right? 10 to the power 6 max operations.
Yes.
Within safe limits we can have. Right? 10 to the power 8 is when at least we have, let's say, max for a safer runtime, we have 2 seconds to run our program. Else it may too or sometimes fail. It may
Clearly.
sometimes tells you that you are running out of time. Time limit exceeded. Think of this problem. How will you solve this? What will happen? Can you code it?
Now, brute force we can.
Yeah, this is only for recursive approaches we are only seeing here right now. Take this as a homework. I guess fairly enough problems we have discussed for this approach, I guess. Is it? Okay, so I am pasting it in your batch. Please solve this using recursion. Correct. These are fairly easy problems. Okay. As well as this edit distance. I'm giving it for a give a thought. How would you solve it? Right. This is a very good problem again. देखो ये आना ही चाहिए, ठीक है ना? ये जो एडिट डिस्टेंस वगैरह ये आना ही चाहिए अगर आप प्रोडक्ट बेस्ड को एम कर रहे हो तो प्रिपेयर ही इतने हो ना कि कोई भी क्वेश्चन थ्रो करे तो कुछ अब लगे ही ना. That's the thing. This is it. And where is it? I'm giving these 2 problems for a because we are again meeting on Friday. Go for this. Have a thought process. How would we solve this? ठीक है, सोच के आओ. एटलीस्ट इंप्लीमेंट ना भी हो, कम टाइम है, 2 दिन का ही टाइम है. एक प्रॉब्लम इंप्लीमेंट करो क्योंकि वो तो बहुत आसान है जो हमने दिया. कौन सा वाला? मनी सम्स, राइट? ये वाला. और एडिट डिस्टेंस मैं तो कहूंगा मनी सम्स को अगर इंप्लीमेंट जरूर करो, कुछ ही देर की बात है. इंप्लीमेंटेशन के लिए ये दिया, मनी सम्स आपको दिया. एडिट डिस्टेंस आप सोच के आओ कि कैसे होता है. अगले दिन इसे जरूर देखेंगे एडिट डिस्टेंस को कैसे सॉल्व करते हैं. ठीक है, हर रोज छूट रहा है बट अब देखने वाले हैं हम लोग. What is it? Removal game. Okay, and we'll definitely solve this problem as well. Removal game. Very interesting question. तो ऑलमोस्ट हमने इतने प्रॉब्लम्स तो देख ही लिए कि हमारे CSCS का कितना प्रॉब्लम
नहीं आ
है.
रही.
व्हाट डू यू थिंक? डीपी सेक्शन से हमने CSCS का कितना बना लिया? 1 2 3. ओके चलो कितना भी हो, आधा तो अभी तक हमने देख ही लिया है, मे बी मोर और लेस. CSCS का देखा है? बताओ कब से देख रहे हैं इसे? कॉइन कॉम्बिनेशन 1 देखा था, एक को शायद कोट किया था, एक आप लोग को दिया था सॉल्व करने के लिए. ग्रिड पाथ्स का सॉल्यूशन इधर है?
हाँ.
4 सॉल्यूशन इधर है. कुछ डेमो क्लासेस में हमने कवर किया, 2 डेमो क्लासेस में हमने रिकर्शन कवर किया था, मे बी याद है? बुक शॉप. अच्छा ठीक है, ना भी हो तो मैं कोड आपका अपडेट. कोई एक क्वेश्चन था ना जिसका हम लोग somehow मैं बोल रहा था कि कुछ कोड नहीं हो पा रहा है, समथिंग लाइक दैट. ये जो है बुक शॉप है. बुक शॉप, ये क्वेश्चन कर सकते हैं, ठीक है। तो इतने तो हमने बना ही लिए अभी तक CSES के, एटलीस्ट चलो 5-6 CSES के हमारे हो चुके हैं अच्छे वाले, एज वेल एज 3-4 लीड कोड के हमने देख लिया अभी तक। हाउ मेनी क्वेश्चंस हैव वी सॉल्व्ड फ्रॉम रिकर्शन, व्हाट डू यू थिंक? 4 का तो सॉल्यूशन इधर है, कुछ के
Around
सॉल्यूशंस
10.
नहीं है जो हमने देखे थे उधर। आपको इनिशियली कुछ बेसिक क्वेश्चंस दिए थे,
I think.
परम्यूटेशन, सबसीक्वेंसेस, ये सब के आप में से कितनों ने सॉल्व कर लिए? तो वो बहुत बेसिक क्वेश्चंस है।
हाँ, किया।
ये यूनिक डिस्टेंस 2-3 देख सकते हैं क्या अभी?
कौन सा?
यूनिक डिस्टेंस, यूनिक पाथ 3
ये किधर है? अच्छा मैं
लीड
देख
कोड
लूंगा,
पे,
ठीक है,
यूनिक पाथ 3।
देखता हूँ, रुको।
इंटरनेट स्लो हो रहा है, I think.
मेरा स्लो है आज थोड़ा,
जी
दिक्कत आ रहा है, पता नहीं इधर क्यों इतना दिक्कत हो रहा है।
एयरटेल लगवा लो भैया, बहुत अच्छा चल रहा है।
यहाँ पे नहीं देता यार, वरना कब का लगा चुके होते। ना तो एयरटेल है ना तो जियो है, कुछ भी नहीं लगा सकते। यूनिक पाथ 3 ये क्या है? स्टार्टिंग क्या है वैसे ये? We have the following path 000।
रिकर्सिव है, रिकर्शन है ये।
I
या
think
पूरा
ये कर लिया है
मोर और लेस तो
CSES
सेम
का।
क्वेश्चंस है जो हम लोग ने देखा है अभी तक।
हाँ, CSES का ये देखा ना,
ग्रिड पाथ्स हमने देखा ना, उसी के जस्ट
लाइक
ये ऑप्शनल वाला है नहीं, ये थोड़ा
नहीं, वो भी ऑब्स्टेकल है, मतलब CSES का।
उसमें ऑब्स्टेकल में तो ये यूनिक पाथ 2 है।
ये थोड़ा अलग है, वहां पे बस
Obstacle
देखो
वाला।
2 ही डायरेक्शन था, यहाँ पे 4
ये 3
डायरेक्शन
में है कि वी हैव टू कवर ऑल द।
यस।
हाँ,
हाँ,
प्रॉब्लम क्या है?
दो more कॉल कर देंगे बस।
प्रॉब्लम क्या है इसमें? मुझे तो कुछ मतलब स्पेशल नहीं दिखता। ठीक है, ट्राई करके आओ, फिर अगले दिन देखते हैं। अगले दिन मैं 2 प्रॉब्लम बताऊंगा आपको, क्योंकि मैंने एक प्रॉब्लम ऑलरेडी आपको बता दिया है। मनी सम्स वाला नैपसैक को कोड करना, ये फेयरली इजी प्रॉब्लम है आप सबके लिए, थोड़ा चेंज होगा कोड में, ज्यादा नहीं। फर्स्ट आई विल बी डिस्कसिंग द एडिट डिस्टेंस, नेक्स्ट ये वाला यूनिक पाथ 3, ये भी मैं आपको दे देता हूँ, फ्राइडे जरूर डिस्कस करेंगे, ठीक है। ये 2 क्वेश्चन आई एम गिविंग हियर ओवर द चैट। 2 problems for sure I am going to discuss. First is edit distance, next is this one। 2 ये बहुत आसान है यार, इसमें मेरे को लगता नहीं हार्ड दिया हुआ है, इसमें कुछ खास होगा नहीं मेरे को जितना लगता है। क्या है, वेक्टर और वेक्टर ही तो रिटर्न करना है, हो जाएगा वो, टेंशन ना लो, ठीक है ना। कैसे करते हैं मैं बता दूंगा पूरा, आप कोडिंग ट्राई करके आओ, ठीक है। ना होता है मैं फ्राइडे को बताता हूँ, ठीक है।
ठीक है।
टाइम कम्प्लेक्सिटी, स्पेस कम्प्लेक्सिटी आज सबको क्लियर है, प्रॉब्लम्स जो हमने सॉल्व किए,
हाँ हाँ, क्लियर है।
ठीक है।